Great. Well, thank you very much for giving me the opportunity to present. And I'm sorry I'm not there in person. I was supposed to be for once. I can't blame COVID. It's just personal stuff that made me uh, prevented me from going. So I'm going to be presenting this paper on macroeconomic uncertainty with Dimitris Georgarikos, Yuri Gorodnichenko, Jeff Kenny, and Michael Weber. And we have a disclaimer given our co-authors that we do not speak for the ECB. Ever since kind of Nick Bloom's seminal work, there's been a lot of talk about uncertainty and its potential role as a driver of business cycles. There's just a little figure to illustrate why this might be the case. We see that during recessions, there are typically large spikes in uncertainty, and so this has kind of generated this possibility that maybe the uncertainty is one of the driving forces of business cycles, either as the shock or as an important propagation mechanism. Intuitively, we can think about mechanisms why this will be the case. So for households, if you're more uncertain about the future, this is going to tend to make you want to spend less. If you're a firm, it's going to give you an incentive to defer making commitments to investment or employment decisions. And certainly amidst with policymakers, we hear discussions of uncertainty contributing to business cycle dynamics very frequently. So for example, here's a quote from Christy Romer in 2009 when she was CEA chair, saying volatility, according to some measures, has been over 5 times as high over the past 6 months as it has been in the first half of 2007. The resulting uncertainty has almost surely contributed to a decline in spending. More recently, during the COVID pandemic, the FOMC had a similar statement saying survey-based measures of consumer confidence also plunged. The development that participants and district contacts attributed to households' concerns regarding the risk of job loss or difficulty in meeting financial obligations. Participants observed that household spending would likely be held down by a decrease in confidence and an increase in precautionary saving. Right, so we see these discussions among policymakers emphasizing the role that uncertainty might play during these downturns. But I've highlighted in bold and red these caveats that they have in their statements, reflecting the fact that there's uncertainty in their statements about how much uncertainty has contributed. And this stems from the fact that the empirical evidence on the role of uncertainty remains somewhat limited. And Nick Bloom had a very nice survey article a few years ago on the empirical evidence, and he characterized this evidence as at best suggestive, and said that more empirical work was needed on the effects of uncertainty, particularly work which can identify clear causal relationships. And the clear causal relationships here is particularly important for uncertainty, because whenever you're trying to quantify the effects of uncertainty, you run into kind of this fundamental identification issue, which I've tried to illustrate in this figure, where the blue line is, again, kind of a measure of uncertainty in the US, and here the red line is a change in the S&P 500 over time. So you can think of this loosely as capturing first moments, and the uncertainty is capturing second moments. Now what you can see is there's a very strong negative correlation between the two, right? And so whenever we have these changes in uncertainty, we tend to also observe changes in first moments going in the opposite direction. And so the question is, how do you separate out these two effects and determine what role uncertainty is playing above and beyond the first moments? So what we're going to do in this paper is take a new approach to try and disentangle these two effects, and we're going to do it through a randomized control trial. So the idea is we're going to provide different kinds of information to different groups of households. We're going to try and induce exogenous variation in both their first and second moments about the future economic growth in the euro area. Okay, so we're going to use the RCT to generate exogenous variation in first and second moments of beliefs. And then we're going to have follow-up surveys of these same households over time to measure their spending in particular, but then also some questions about their desire of investing in different kinds of assets to determine how that change in uncertainty that we tried to induce in the first stage ultimately affects their spending decisions. So we're going to interpret this as providing clear causal evidence that uncertainty does in fact affect household spending. All right, so let me describe kind of the ideal setup of what we're trying to do, since most of us macroeconomists are not experts in RCT methods. So the idea is you're going to start with a large cross-section of households, and you're going to measure their prior beliefs, so their initial expectations, both first and second moments, as well as their plans for what they're going to be doing in the future. Excuse me. So with households, for example, this is how much they're going to be spending, whether they plan to do any large durable good purchases, etc. And then you break these households into different groups randomly. One group you do nothing to. You call that the control group. The other groups you're going to provide some kind of information to, and the hope is that that information is going to lead them to think differently than the control group. Okay, so you're going to try and change either their first or their second moment or both of their expectations. And so then you want to be able to measure whether you have in fact changed their expectations. And so you want to go back to these households after the treatment, and you want to measure what we're going to call their posterior beliefs, right? So those same expectations after these treatments, both for first and second moments, right? This allows you to determine whether these treatments that you did in fact change their economic expectations. Right, and then the next stage is, having changed their expectations, you want to see if this actually does anything to their decisions. So you want to go back to these households or firms, depending on who you're looking at, later on and measure ex post their decisions. Okay, so in our case, we're going to be looking at primarily spending decisions. And so then the idea is, because you've randomly changed the beliefs of different households, this is going to be able to break through this identification issue that we face in macro data and allow you to speak to the extent to which changes in first and second moments are going to affect these decisions ex post. All right, so that's what we'd like to do. So the way that we're going to do this in practice is we're going to use a monthly panel, monthly survey of households that the ECB has been running for a while in 6 countries. Okay, so we're going to have Germany, France, Spain, Italy, and in those 4 countries we have 2,000 households a month that are being surveyed, and then Belgium and the Netherlands, in which there's 1,000 households being surveyed. So together we have 10,000 households each month which are participating in this monthly survey that the ECB has been doing. So in September of 2020, the ECB allowed us to add some questions to their regular survey. Not very many, so we have about a 10-minute bracket of people's attention. And so what we do there is we try and measure these initial beliefs about the economic outlook. And so we're going to focus on beliefs about growth rates in the euro area. And so the way we do it is, initially we ask a very simple question. We ask people, please give us your best guess about the lowest growth rate and the highest growth rate for the euro area over the next 12 months. Okay, so we have a min and a max, and so we can use that to create both a mean forecast and a measure of dispersion. Then we're going to do our information treatment to a randomly selected subset of these households, and as I'll go through, we have a number of different treatments, and I'll come back to these. And then we go back to them immediately afterwards and ask them kind of follow-up questions that are meant to measure their posterior beliefs. Now, you don't want to ask households the same question over and over in a survey, because they stop responding and participating, so we have to ask a different question. And the question we asked is a variation on a formulation that Nick Bloom and co-authors came up with for firms, which was meant to measure their uncertainty. And this is, we asked people to give us growth rates for 3 different scenarios, kind of a low scenario, medium scenario, and a high scenario. And then after they give us those growth rates, we ask them to assign probabilities to each of those outcomes. Okay, so that way you get a probability distribution over different outcomes, but it's the household themselves that specify what are the different bins that they're considering. Okay, again, from this you can construct a mean forecast and a measure of uncertainty. Yes?
Can you show just again the first question, like to measure prior belief?
Yeah, so the first question is just, we asked for a low value and we asked for a high value. We also asked a question where you ask them, what is the probability that you're going to be above or below the median of these two, or the mean of the two? And so then you can do like a triangular distribution. In practice, it doesn't add much relative to just using this very simple version of the question. And so most of our results are based on this very simple question.
Thanks.
So this gives us our posterior beliefs, okay, all within the same survey. But then in addition, every 3 months in the regular ECB surveys, they ask households to provide kind of very detailed responses, breakdowns of how much they have spent per month on different types of consumption categories, as well as whether they have purchased durable goods of different kinds. Okay, so 1 month after the experiment, we can observe spending decisions, and then 4 months after the experiment, we can again observe spending decisions. Okay, so that's going to give us the ex post measures of decisions for our purposes. All right, so let me describe the treatments. Okay, so remember, so we have our households, we break them into different groups. One is the control group that gets no information. Okay, then we're going to have 4 different treatment groups. So the first is just going to be told that the average prediction among professional forecasters is that the euro area economy will grow at a rate of 5.6% in 2021. Okay, so they get this quantitative forecast, mean forecast from professionals. And then we add a qualitative statement which says, by historical standards, this is a strong growth. Okay, so that's the first treatment. This was meant to move the first moment of household beliefs. Okay, at least that was our prior as to what this would do. A second treatment then was meant to primarily move the second moments. So here we tell households that professional forecasters are uncertain about economic growth in the euro area in 2021, with the difference between the most optimistic and the most pessimistic predictions being 4.8 percentage points. By historical standards, this is a big difference. Okay, so notice again, there's a quantitative statement. We tell them how much dispersion there is in beliefs, and a qualitative statement that tries to make them think this is a big, this is a high amount of uncertainty. So notice the way in which we're making a statement about uncertainty is by telling them about the difference between optimistic and pessimistic forecasts of different forecasters. So this is actually measure the spread in forecasts. It's not a measure of the actual uncertainty in the forecast of professionals. And we did this because we were worried that providing a statement about the standard deviation in a professional forecast was going to be too complicated a statement for households. So instead we provided this measure of the spread in forecasts. Okay, so we have one treatment that was meant to hit the first moments primarily, a second treatment which was meant to hit second moments primarily, and then a third treatment which just combines the two. Okay, so the third treatment, we tell them the average forecast of professional forecasters, and we tell them what is the spread between optimistic and pessimistic forecasts.
Can I ask a question?
Absolutely, please.
Yeah, so about the treatment too, I don't know, I'm a bit confused about what is the meaning of that, because you want to measure the certainty that the household has, so you want to shock their uncertainty, But here what you're telling them is there is more uncertainty around, which is a different things. It's like you're changing, you may be changing the first order also. They say your belief about how much uncertainty, it may be wrong, but it's not affecting their own uncertainty necessarily, right?
Yeah,
That
so
is what
I mean, it very well could be the fact that these treatments, any of them, have no effect on households either first or second moments, right? So the treatments can fail to move people's uncertainty. That's why you want to measure their beliefs after the treatment to see to what extent you did or did not move their beliefs. Okay, and I'm going to show you, in fact, that we have a treatment that completely failed in this sense. But these three treatments will be successful in terms of moving people's beliefs, and I'll show you exactly how.
Can I ask a follow-up question on that? The treatment two
Yes.
gives them information about disagreement.
Yes.
Right? Yes.
That's right. So we gave them the information about disagreement, thinking this was more likely to move their uncertainty than if we told them, you know, the standard deviation in a professional forecast is 3.2%. And we'll, you know, again, we'll be able to assess to what extent this did move their uncertainty or not. Okay, then we added a fourth treatment, and the fourth treatment was the spread in forecast about economic growth in their specific country. Okay, and at the time, the quantitative numbers were pretty similar for all the different countries. There was always a lot of disagreement about what was going on. And the thought here was, well, you know, maybe if we tell people about Euro area growth, it's not gonna do much to their beliefs. So let's tell them something that's specific about their country. Okay. In practice, as I'll show you, this didn't do much of anything, at least to their beliefs. Okay, so we have these four different treatments, right? Then we want to measure their posterior beliefs. We want to see to what extent did this change their views about anything. And so what I'm going to show you is I'm going to show you figures comparing people's posterior beliefs to their prior beliefs, right? So if you're the control group and you got no information, right? In principle, your posterior should be the same as your prior. So if I show you a scatter plot of prior beliefs against posterior beliefs, it should be aligned with the slope of 1. Right? And if the slope is a little less than 1, that can reflect kind of measurement error from questions, using different types of questions, etc. But on average, right, your posterior should be your priors. For the treatment groups, right, your posterior belief in general should be a weighted average of the prior belief and the information from the signal that was provided to you, right? How much weight you place on that signal is the gain, the Kalman gain here, and it's gonna reflect how informative, how precise households think that signal is, right? So one possible outcome, again, is we give you a signal, you think that signal has no information content, has no value, so you would put a weight of 0, and your posterior would again just be equal to your prior, just like the control group. Alternatively, you could think, oh, the signal is super informative. I'm going to put all my weight on the signal, right? And so then everybody's posterior would be equal to the signal, and their priors would be irrelevant, right? But more generally, we think it's going to be some weighted average of the two. And so this weight that people place on their prior here is going to speak to how informative they thought the signal was. And so what I'm going to show you, I'm going to skip the econometrics and just show you graphical versions of how the treatments affected people's both first and second moment beliefs. Okay, so I'm going to do it through these figures that are taking people's prior expectations. I'm going to plot them against their posterior expectations, and I'm going to show you bin scatter plots of the relationship between the two. Okay, so we're going to start with the control group for their mean forecasts of Euro area growth, right, from the two questions that we gave them. So for the control group, you can see there's a strong positive relationship. The slope of the line is a little bit less than 1, okay, which reflects the fact that we're using different questions to measure these two concepts. That introduces a little bit of measurement error in there, and so the slopes end up being a little bit less than 1, but not by very much. Okay, but more or less as you would expect, when you give people no information and you measure their priors and their posteriors, they line up. Okay, so the wording of the two questions is kind of close enough that we're correctly capturing the same content. You know, so people who thought growth was going to be 0, using one question, when you go back to them and you ask them the other question, also tell you a growth rate of 0 on average. All right, so then what happens with the information treatments? So with the first treatment, and this is where we tell people the average forecast of professional forecasters, we get the relationship given by these red squares here. And so you can see there's a positive correlation between priors and posteriors, right? But the slope of this relationship is much, much flatter than the control group, right? So if initially you thought the growth rate of GDP in the Euro area was going to be 10%, after we tell you what professionals think, you revise your expectation down to 6 or 7%. Okay, and the same thing on the low end. So that first treatment that was meant to kind of hit those first moments is very successful in moving people's first moment expectations. The second treatment, which is where we tell people the dispersion in professional forecasts, has essentially no effect on the first moments of people's expectations. Okay, so they don't revise their views about the average growth rate of GDP. The green line is basically on top of the control group. Okay, so we have two different treatments. They have very different effects on the first moment of the expectations. The third treatment combines the two and kind of not surprisingly has the same effect as the first treatment, right? People are responding to the information about the average forecast of professionals. And the fourth treatment, as I mentioned, is going to be a fail and does not move the first moment of beliefs at all. All right, so that's the first moments. We have two treatments that are moving the first moments by about the same amount. Okay, and then two treatments that don't move the first moments at all. So then we can look at the second moments. Same idea, right? So we have a prior belief about uncertainty, a posterior belief about macro uncertainty. For the control group, right, you have this strong positive relationship. We haven't given them any information. Again, the slope of the line is a little less than 1, right? We've got two different questions measuring uncertainty. And then we ask, all right, how did their uncertainty change given the different pieces of information that we gave them? So with the first treatment group, right, so when we give them information about the average forecast of professionals, you can see this has a pretty significant effect on their second moments, right? So if initially you were very uncertain, you revise your uncertainty down, and it's a little hard to see in this figure, but if initially you had very little uncertainty, you revise your uncertainty up. Right, so that first treatment, which was a treatment about the first moment, moves both first and second moments together. The second treatment, right, which was about the dispersion in the forecasts, also affects people's uncertainty, right, by slightly less than this other treatment, but this also moves the second moment. So the second treatment, which had pretty much no effect on the first moments, has an effect on the second moments. The third treatment, which provided information about both the first and the second moments, has an even bigger effect on second moments than the first treatment. Right, so now we have another treatment which had a strong effect on the first moments and has a very strong effect on the second moments. And then a final treatment, our fourth treatment, which, as I mentioned, is a fail, right? And this one basically is on top of the control group. So this fails to generate any meaningful changes in either first or second moments. Okay, so this kind of illustrates when you do these RCTs with information treatments, they don't have to work in terms of changing people's beliefs, right? If you give them information that either they know or that they think is not particularly relevant, you're not going to generate changes in beliefs. That's the case with the fourth treatment. Okay, so in practice from now on, I'm gonna ignore it because it doesn't work in terms of the first stage of the process of generating people's beliefs. Okay, so let me kind of summarize what we get from these treatments by putting the two figures next to each other. I know it's a little hard to see, but all I really want you to take away from this is that these different treatments are inducing different relative movements in the first and the second moments of people's beliefs. Okay, so we have treatments that generate big changes in first moments and others that generate no changes in first moments, and then treatments that induce changes in uncertainty by different amounts. Okay, so the key that we need for our purposes is that we're able to change first and second moments by different relative amounts across the treatments. That's where the identification is going to come from. All right, so once we have this is basically the first stage. We're going to get to the second stage, which is asking, how does spending ex post respond to changes in beliefs? All right, the way we're going to evaluate this is through the specification at the top, where we're going to take these ex post measures of spending at the household level, and we're going to regress them on people's posterior first and second moment beliefs. Right? So what do they think the growth rate of the GDP was going to be? Was there uncertainty about the growth rate of GDP? We're going to control for their prior beliefs. We're going to control for a bunch of households characteristics. And then we're going to instrument for these posterior beliefs, the first and the second moments, using our information treatments. Okay, so the first stage is really just going to be the figures I showed you. We're going to take these, say, the posterior second moment, and we're going to regress it on indicator variables for which treatment group you were in, and then interact those treatments with people's prior beliefs. Okay, so we're really just using those figures I showed you. That's our instrumenting strategy. Right? And the fact that the treatments are inducing different relative changes in the first and the second moments is where the identification is going to come from. Okay, and so these coefficients alpha 1 and beta 1 are going to tell us by how much does spending ex post respond to changes in uncertainty. Okay, after controlling for first moment effects. So let me show you what we get. So here this is going to be looking at the total change in, or the total spending 1 month after the treatment, right? And we're going to show you the coefficients on the second moments here. But before I do, I want to show you the first stage F statistics. I want you to note these are kind of really high by the standards of macro, yay, we have strong instruments. Right, so what do these tell us? Well, what we get is a statistically significant negative coefficient on uncertainty, okay, which says when households uncertainty goes up, 1 month later, their spending is lower. Okay, this magnitude of about 5%. This is for a 1 unit change in uncertainty, and that's about a 1 standard deviation increase in terms of the cross-sectional distribution that we have in uncertainty. Okay, so this is having a pretty large effect on spending. Okay, if we go to 4 months later, so this is column 4, we get the same effect. That increase in uncertainty is having a persistent negative effect on household spending 4 months after the treatment. Okay, so that's the punchline of the paper. That's the main result that we have. So how am I doing on time? Would you mind?
You have 10 minutes.
10 minutes. Okay. So let me show you.
Can I ask you a quick question? So
yes, absolutely.
So in the posteriors, the average, the unconditional average of growth change. So independently of the slope. So on average, people were thinking there was 5.6 also, or around that.
The average forecast, you mean the first moment?
Yeah, the unconditional first moment, because you show.
No, they don't change terribly much. I mean, you can sort of see from the bin scatter,
Exactly.
right, that the average was here. It's kind of tilting around on average. We're not finding a big change across everybody.
So your treatment doesn't change in general the first moment even. It just changes. I mean, you think the unconditional average.
Well, yeah, I mean, it's causing the optimistic people to become less optimistic and the pessimistic people to become less pessimistic.
Exactly.
Okay, and
And
so
that's it.
then we're looking at essentially how does the spending of the optimistic people who become less optimistic change relative to the other ones.
Yeah.
But we're able to separately identify the first and the second moments through the instruments. Okay, so there's obviously because the spending data is available at the level of the category. We can look at which categories of spending change the most, and so what we find is that the decline in spending is most pronounced for spending on recreation, kind of general personal care categories. Yeah, so this result I think is kind of interesting because this was done during COVID, and these are categories of spending that were particularly hit by COVID, and so it may be the case that the specific categories of spending which responded here were related to the fact that this was done during COVID. But overall, we see declines in all categories, but they're particularly pronounced for these categories of spending. Let me show you some results on durable goods. So again, because households were asked in the first wave, whether they expected to purchase durable goods, we can look at ex post whether their durable goods purchases were different than what they expected. Okay, so we're going to run kind of the same regression here of but where the ex post variables are an indicator of did you purchase a home? Did you purchase a large durable good like a refrigerator? Did you purchase a car? Did you go on holiday? Did you purchase an expensive luxury item like, fancy watch or jewelry? We can condition on whether people were planning to buy one of those things initially. Okay, so we're essentially looking at kind of surprise purchases or surprise lack of purchases and look at how those relate to their uncertainty. And so here I want to note, we have negative coefficients everywhere. They're significant only for holidays and luxury items, right? The difficulty we run into here is with the very large purchases like homes and cars. These are very infrequent, and so we don't see them very often in the data. Right, so there's very few people that are kind of either buying or not buying a home when they were planning to, and so we just don't have very much identification here. So our guess is that these effects are insignificant because we just don't have enough of them showing up in this cross section of observations. With things like holiday purchases, jewelry purchases, these happen much more frequently, and so we're able to identify the negative effect there. Now, we were only able to ask our questions in this one wave, so we're not able to assess the persistence of the treatments on people's macroeconomic uncertainty over time, because we're only able to measure this uncertainty in September. However, in the regular ECB survey, they ask questions about microeconomic uncertainty. So they ask people about their uncertainty for their own future income. And so what we can do is look at whether our treatments affected people's microeconomic uncertainty over time. So here what I'm going to show you is regressions where the dependent variable is people's the uncertainty that they report about their own personal income growth 1 month after the treatment, 2 months after the treatment, 3 months after the treatment, right? Regressed again on these ex ante, the posterior beliefs for the first and the second moments. Okay, and we can condition on their initial micro level uncertainty. And what we find is that, when you become more uncertain about the macro outlook, this does translate into greater uncertainty about your own income growth 1 month after the treatment, 2 months after the treatment, and then it kind of tapers off at about 3 months after the treatment. That's where we can no longer find any effects. Okay, but this change in views about the macro outlook does seem to also generate uncertainty about their micro, about personal income. We also had some questions about financial portfolios, and so in my last couple minutes, I'm going to show you these results. And so here what we did is in the September wave, after doing the treatments, we asked people a hypothetical question, which is, suppose that you were to receive 10,000 euros that you could invest in financial assets. How would you allocate this 10,000 euros across different categories of assets? Okay, and we know initially, because there's a similar question that's asked in a regular survey, we know what people's actual allocation is in their portfolios. But we also know that people don't change their financial portfolios very often. So we thought it would be too much to try and assess whether this led to an actual change in portfolio. So instead we look at this hypothetical to see if changes in uncertainty affect how people report that they would allocate this money. And so what I'm going to show you is kind of the shares, the change in the shares that people would assign to these different types of investments as we change their uncertainty after conditioning on how much of their portfolio is actually being held in these different types of assets. All right, and what we get is that we see a decline in the share of this 10,000 euros that households would allocate to mutual funds and cryptocurrencies when they become more uncertain. Okay, so as uncertainty goes up, we see some evidence of a reallocation away from these kind of riskier assets taking place, at least in this hypothetical question that people are responding to.
So, but where does it go? I mean, shouldn't.
Yeah, so we can't, we're not getting like positive effects here, and we're not forcing the terms to add up to zero. We're doing these regressions kind of one by one, and so there's, I mean, it has to go to one of these other categories, but you can see the standard errors are pretty large, and so we can't tell if if it's going into bonds or something else.
It's tricky because you may think that mutual funds maybe are less risky, right?
Well, you would think they would be less risky than like the direct holdings of stocks. But again, there's a lot of noise in these, and so we don't find any meaningful effect on what people are putting in their in the stocks. It could reflect the fact that just a lot of people don't hold stocks kind of directly other than through mutual funds in their retirement portfolios, and so they're just they say zeros for a lot of the time. Here there's a little more action because it's a bigger category. I'm not sure. On the other hand, we see a response for cryptocurrencies, even though this is a minuscule share of people's total investments. Yeah. So yeah, and then we try and look at whether certain households respond more or less to uncertainty than others. Unfortunately, there's a tremendous amount of noise in the data because spending is self-reported, so there's a lot of noise in that. Expectations in surveys are very noisy as well. And so as soon as we start to slice and dice the data, the noise kind of explodes, and we're unable to identify much in terms of heterogeneous effects. There's a couple of exceptions to that we find. So one is that we find that people who are working in sectors that were more exposed to COVID risk were responding more to the uncertainty in terms of their spending than people that were working in sectors that were less exposed to this type of labor income risk during this time period. We also find that people who are holding riskier portfolios ex ante tended to respond more to changes in uncertainty than those whose financial portfolios were less exposed to risk.
So Olivier, can I come back a little now that you're talking about this? Could it be, could I interpret this lack of positive like the people have a default that is cash? that when they don't say that they could reduce the fundings in your question, could it be that they interpreted like they don't put the money in any investment? Like would be like an increase in cash holdings.
It could be in cash. I mean, so we do have a saving account category, which was meant to, you know, you put your money in your saving account and it just sits there. But you're right that in principle, you know, they could be thinking we're going to hold more in cash.
So I will discuss this very interesting paper. I think Olivier did a great job, and in combination with Facundo, essentially they spoiled most of my discussion. But you know, as Olivier was suggesting, so there is a huge. I mean, there is growing literature. Looking at or speculating that uncertainty may be an important driver of business of the business cycle, and in particular may affect the business cycle through aggregate demand. Okay, but what we are really lacking, direct empirical evidence on the effect of uncertainty to demand. And this is what this paper is providing into the literature. Okay, so it's the first paper providing causal relationship between changes in uncertainty at the individual household level and individual behavior, in particular demand, asset allocation, and so on and so forth. And you know, I think it should be clear now that the way this is done is by RCT experiments, where the innovation relative to the past is that now individuals, households in this case, are provided with information on disagreement of professional forecast, which is a proxy for overall uncertainty in the economy. Okay, on top of a standard by now type of RCT that provides information on in this case GDP growth, or in other experiments inflation and other macroeconomic variables. And once you get this differential variation between changes in individual posterior due to changes in posterior mean, as opposed to changes in posterior uncertainty and second moments, you can ask yourself, okay, how are individuals responding differently to changes in this first and second moment of the posterior distribution. And the paper does an excellent job at documenting the effect of first and second moments, uncertainty, and average expectations on durable, non-durable consumption, personal income growth, and asset allocations. Okay, so just a review. So the treatments are, fairly successful in the sense that providing households information about what professional forecasts think on average of GDP growth is moving their posterior expectation of GDP growth. Okay, so this is what this first graph is about. So when you compare the control group, the black line, to the red and blue lines that are the treatments which provide information on the first moment of GDP, you get a strong, significant effect on their expectations. And even more interestingly, okay, so these, I think we should sort of know already by in the existing literature that individuals are responding to communication, but this is, I think, the key and the innovative piece of information that this paper is providing to the literature, is that now individuals not only respond to communication about first moments, but actually their expectations get revised also if you provide them information about second moments. Okay, which is potentially an additional instrument by which policymakers could manage individual expectations. Okay, and I guess Olivier did a great job about discussing the effect of the different treatments on posterior uncertainty, so I'm not going to spend much time on it. The only thing I want to emphasize is that, so I think what was surprising to me reading the effect of the treatment on uncertainty is that the wording of the treatment is very clear about the fact that the level of uncertainty, disagreement of professional forecast was at an historically high level. Okay, so there is a 4.8 percentage points difference among the percentiles of the distribution of professional forecasters, and despite providing households with this information, their posterior uncertainty is falling. Okay, which suggests that households actually had an even larger uncertainty to start with. Okay, so that you are telling them that professional forecasters have a disagreement of 4.8%, and they take this as a good news in terms of where uncertainty stand about GDP. Okay. Now, let's get to what I think is then the most interesting implication of this paper. Okay, so what is the effect of now providing information, communicating households about average GDP growth as opposed to second moment of the distribution of GDP growth? Okay, so what is very interesting in this paper is that if you look at the first moment, so posterior mean, there is no statistically significant effect of providing communication information on consumption, and if anything, it has the wrong sign with respect to what standard model would think of. So if you give households or if you have good information, good news about GDP growth, you would think that consumption will go up. Here instead is not statistically different from zero. If anything, is negative. Instead, there is a very large a negative effect of uncertainty on consumption. Okay, and the question now that the discussion and now I want to have is on what could be the reason why we have this strong effect of uncertainty on consumption, and why don't we have a similar effect with the treatment on the mean, on the average. Okay. Now, first hypothesis is the uninformative signal. Okay, which I could also name now the Facundo hypothesis. So we are giving households information on the posterior mean, also what professional forecasters think about the average growth. And the household could just ignore this information because they may think, okay, these professional forecasters, they do nothing, so I'm not going to change my consumption because of the average expectation of professional forecasters. But when you look at the data, okay, this is not the case, obviously, for two reasons. So first, we saw that the posterior mean is responding to the treatment of average inflation, average GDP growth. And second, if we look at the behavior of households in response to how they change their asset allocation in response to the different treatments, we do find that they do respond in terms of asset allocation to information about the average growth rate of GDP. For instance, in this case, they would invest more in stocks and less in cryptocurrencies. Okay. And I think this was touched already in the discussion. So I think it's surprising that you are increasing uncertainty, so you are reducing the saving account, reducing the mutual funds, but you are not reducing the investment in stocks. Okay, so I really don't know how to interpret this from a modeling sort of theoretical perspective. Now, hypothesis number two. It's what I call the sophisticated households. Okay, so think of now households having in mind our models. Okay, so they think that the nominal interest rate sort of follows some form of Taylor rule that depends on inflation expectation and GDP expectation of GDP growth. Now, if I tell households that the GDP is going to be higher, as in the treatment of this paper, they might expect higher interest rates, and as a result, they might want to consume less, okay, because of that. Okay, so we have two offsetting forces, higher income, higher consumption, but higher interest rates, lower consumption. So this might explain why consumption overall is not responding in the data. How about uncertainty? Well, this is a little bit more convoluted. So I give information on uncertainty to the households. They feel less uncertain. They expect lower inflation. As a result, they expect lower interest rates by monetary policy, and consumption goes up. Okay, so this would be a mechanism by which providing information on uncertainty to households, I stimulate aggregate consumption. But what I'm missing in this story is, okay, so what is, why shall I have inflation expectation falling to uncertainty? Well, I thought I browsed I asked the internet, so I asked Google, and what Google gave me, it gave me a recent ECB economic bulletin, which is actually making the case that if you divide households, European households, in two groups, uncertain households and certain households, what you find is that the certain households, which are the blue, the guys here here in blue, as opposed to the uncertain households, the guys in yellow, have very different levels of inflation expectation. So certain households are reported on the left axis and have much lower inflation expectations than uncertain households on average. Which means that if you now communicate to households about the uncertainty, so you reduce uncertainty of the average households, you may reduce average inflation expectations overall in the economy, and maybe this would explain the response of consumption through this feedback about monetary policy. Now, do I believe this story? No. So that's why I come up with the third hypothesis, which is the COVID case. Okay, so
Luigi, just time management, like you should be done soon-ish.
Yeah, it's 7 out of 10, so I'm almost done.
Okay.
So the COVID hypothesis, okay, so this came up in the discussion. So it could be that uncertainty is perceived as a proxy for infection risk. Okay, so that what is really driving economic uncertainty behind the scenes is uncertainty about how what kind of risk I face in terms of infection. Okay, and today we learned that actually the infection risk is not so low. And if you look at in fact the effect, so which kind of sectors uncertainty was affecting the most. So you see that expenditure was falling the most in for holidays, luxury, healthcare, and recreation. Okay, so with the exception of luxury, so the other sectors are all sectors that are pretty much exposed to COVID. Okay. So last piece of evidence corroborating this hypothesis. So as Olivier was suggesting, so if you now divide households working in sectors exposed to COVID or not, so you see that households exposed to COVID directly are the ones whose consumption responds the most when you provide them with the treatment about uncertainty. Okay, and similar for asset allocations. Now let me conclude with what are the implications? What could be the implications of this evidence for macroeconomists, and in particular for people working with models? So I think there are mostly two kind of branches in the literature that think about the effect of uncertainty for the business cycle. So one is going through the relationship between the interaction between precautionary savings and risk, and the effect on consumption. Now, if I take the numbers from this paper and I do a very rough analysis, so this paper is telling me that a 5% reduction in consumption is following to a 1% shock to standard deviation. So it's pretty large response of consumption. If I take what probably is the benchmark now in the literature for the effect of uncertainty on household demand, on consumption, which is Basu and Bundig, Econometrica 17, here, to a 1 standard deviation shock in uncertainty, I get a much smaller response of consumption, so 0.2%. So we are an order of magnitude smaller than what is in this paper. Now, of course, we are comparing apple and oranges, so this is not necessarily the same uncertainty shock, but is suggesting that we may have a hard time replicating this co-movement. And then the other branch of the literature is night and uncertainty, which has the advantage of providing a sort of an amplification of the effect of uncertainty on demand. And here, uncertainty can have first-order effects on consumption, and so you potentially could accommodate these large responsiveness of demand to uncertainty shocks. Okay, so which then the bigger question here, okay, what are we measuring here? What kind of uncertainty is risk, or is a Knightian type of uncertainty? Okay, and I conclude. So it's a very interesting paper, and I sort of try to speculate on how we could use this data to discriminate across different kind of models. And of course, on the policy debate, so this paper has important implications for how we should and could manage households' expectations. Okay, so thank you.
Thanks, Luigi, for the very interesting discussion. So I guess we can take 5 more minutes to answer. I don't know if there are more questions, and then Olivier can answer to both the discussion and the possible additional questions. If someone has an urgent question and cannot ask it, you can send it in the chat as well.
Yes, one.
So actually, Facundo wants to speak again.
Sorry, I know I'm very annoying when I'm annoying, but you didn't use the heterogeneity across countries. I wonder if there is part of the explanation, because I don't remember exactly, but I think I saw that in some countries it wasn't significant, while in others was, like, I think Italy was very significant, and maybe Spain, but in Germany, Netherlands, it wasn't. And I wonder if that could be used to understand where the effects could be coming from. That's it. I don't ask more questions.
Thanks. So then I think, Olivier, you can answer to whatever you want to answer to.
Well, thank you very much to Luigi for the very thoughtful discussion. Yeah, let me just say a couple things. So one was on the point about the qualitative versus quantitative guidance that we provide in the treatments. So when you do these surveys with a treatment, one of the difficulties is you only get one shot at it, right? So you have to set it up, and then you hope everything's going to work, and so you try and set it up so that so you try and anticipate things. And so our concern was, if we give a number about uncertainty, macro uncertainty to a household, they're not going to understand it. It's not going to shape their view. And so that's why we did a combination of both qualitative and quantitative guidance within the treatment. So we said, the dispersion is 4.8%. This is really big, right? We're trying to get people to think, oh, there's more uncertainty. Our expectation was that the qualitative guidance would kind of, would be really powerful, and the quantitative one we didn't think would do much. One of the interesting things I think that comes out of this is that wasn't the case at all. It seems like people ignored the qualitative guidance and actually used the numbers, right? Because you see the optimists and the pessimists moving in the right directions each time. So we were surprised by this. Ideally, what you'd want to do is you'd want to have a lot more treatments where you can separate, you can have some people getting qualitative guidance, other people getting quantitative guidance, some getting both, and disentangle the two. Unfortunately, our cross section was not big enough to allow us to do this, so we had to pick 4 treatments that we could do, and so this is how we separated them. But we were also surprised that the quantitative component was more powerful in certain cases. In terms of the mean forecasts, not having much of an effect, we had the same reaction as Luigi, which is, well, that's pretty surprising. And in other contexts, we have found that first moments will affect spending of households, just not, we never did first moments of GDP growth like this. And so my interpretation of this, and it's pure speculation, would be closest to Luigi's third story, having to do with kind of something. I guess I thought of it in terms of like large disaster risk. When I tell you a statement about uncertainty and there's these possibility of really bad outcomes, that's going to induce a response of households because they want to protect themselves against that really bad case. But mean forecasts, whether your mean forecast of GDP growth is 2% or 3%, the link between that and whatever is going to happen to your income is probably pretty low, and so that's probably not strong enough a channel to get you to respond. But if you're just worried about the really bad outcomes, and you see a big change in that probability, I could see how maybe that would have more of an effect. So that was the interpretation that we had, but we agree it was surprising, and it'd be great to be able to do more on that. And then the last question was on the cross country analysis from Facundo. Yeah, I didn't go through the cross country stuff. So we find effects that are kind of more pronounced, that look more pronounced in Spain and Italy than in the other countries. They're statistically significant in the Nordic countries in one case, I think, but not the other. Our thought is this is more just, again, a reflection of as soon as we start to slice the data, our standard errors kind of blow up. And so we lose precision in the estimates. There is some indication that the effect is bigger in one group of countries than the other, but again, we can't say it with certainty, and we don't have, it's hard to say what's driving that in this case. We don't have enough kind of variation, I guess, across countries to speak to the sources of any cross country differences that we observe. So we're not sure if it's just there's measurement error that's giving us what look like differences, or if it's capturing something more fundamental. And if there is something more fundamental, we don't have enough identification to speak to what would be driving it here. But thank you very much for the comments and questions, and the opportunity to present here. I really appreciate it.